Thank you very much. It's a pleasure to be here this morning. I thought I'd start out by thanking you all for having me here, and then also by apologizing for my voice. Excuse me. I've had a cold for the last week or so, and it seems to be lingering, its effects lingering most in my voice. This is not the worst problem with my voice I've ever had while speaking. A few years ago, I went to a conference and I was scheduled to give a talk, and the night before, this cold hit me, and by the next morning, I literally could do not much more than whisper. So I went to the organizer of the conference, who was one of my colleagues, and I said, you know, I don't know if I can do this today. I really can't speak very well. And she said, no, come on, you know, we'll get you a microphone. We'll make sure that everyone can hear you. And so I grudgingly went along, and I had this microphone, and I held it up like this so that my voice could be heard. And somehow I got through the talk. And when the talk was over, my colleague thanked me, and she said, you know, I've never heard the room so quiet as when you were speaking. They really were listening to your every word. I think it's because they thought that at any time, your next word could be your last. So hopefully that won't happen this morning. My voice will hold up a little bit better than it did that day, and it won't be too tough on your ears, because I'd like to share with you sort of the backdrop for the other talks that you're going to hear today, and that's a little bit about the issue of climate change. And I'm going to talk mainly about the causes and impacts of climate change, but also begin a discussion of what the solutions to climate change may be, and then the speakers that follow me in the program will have even more to say about that. Now, probably many of you know the basics. The Earth's temperature has been rising. This is a graph of temperature for the past 125 years or so. Each little black square is the temperature for a particular year. And if you look for a temperature like 72 or 23 on the left axis there, you won't really see that, because this is the difference between the temperature at any time and the average temperature for the period from 1951 through 1980. So that's how we've defined the zero line. We plot a black square for every year, and then the red line seeks to smooth out some of those year-to-year ups and downs by averaging the temperature over a 5-year period. And what we see is that the global temperature has risen by about roughly 0.8 of a degree Celsius over the course of the 20th century. So in terms of Fahrenheit, that's about 1.25 degrees, a little bit more than that maybe. And the warmest years have all been in the last 10 years or so, 1998, 2005, 2007, all very warm years. We still have a few days to go. 2008 is probably going to come out down here somewhere. We've had a La Nina, a cooling of the waters in the Pacific Ocean this year. When that happens, the temperature dips down a little bit. This was a La Nina back here, and you can see this big dip was associated with that. But we try to ignore the little ups and downs from year to year and keep our eyes focused on the overall long-term trend. And the long-term trend has been rising temperature, with the rise in temperature being particularly large over the last 30 or 35 years. Now, along with that rise in temperature, some other things have been happening as well. This is a chart showing what the Arctic sea ice has been like for the past, roughly 30 years, since we've had satellites up there to measure it very, very accurately. And just like the temperature curve shows ups and downs from year to year, so too the sea ice curve shows ups and downs. There has been a long-term downward trend, but last year in 2007, the ice amount plummeted. September is the end of the summer. That's when the ice is smallest in the Arctic. And last year it dropped to about 2 million square kilometers less than it had been in any previous year. Now, 2008 isn't plotted here, but I looked at the data when I was putting this talk together. I don't have a chart for it, but it came up to about this level. So it was a little bit higher than last year, but still very much lower than any of the previous years. And to give you an idea what that looks like, this is the Arctic Basin. We're talking about sea ice. This is ice that floats on the water, not the ice that covers the entire continent of Greenland. And in 2007, the area of ice corresponded to this white area here on the diagram. The previous low season was 2005. That's this green outline that maybe some of you can see if you're sitting up front. And the average for the 1980s and 1990s was this yellow line way out here. So really a very large reduction in sea ice by the end of the summer. Large parts of the Arctic Ocean having no ice at all. And the Northwest Passage, which was sought by the early European explorers in the 16th and 17th centuries, is now open at least part of the year, as there is little or no ice in these channels between the islands in northern Canada. So not only are we seeing global temperatures rising, but we're also seeing big changes in sea ice. The reason for this, or at least the primary reason for this, is that as most of you know, by burning fossil fuels, we are emitting carbon dioxide into the atmosphere. This picture at the top is a picture of the Mauna Loa Observatory in Hawaii. Now, why do we have an observatory on Mauna Loa in Hawaii? Is it because scientists like to go to Hawaii? Well, they do like to go to Hawaii, at least I know one scientist who does, but that's not the reason why the observatory is here. The observatory is here because Hawaii, sitting as an island in the middle of the Pacific, if we want to measure what's in the atmosphere, it's a very good place to do that. The trade winds blow almost 365 days a year. They blow out of the northeast. This is sitting on the northeast side of a very tall mountain on one of the easternmost islands. So there are no tailpipes or smokestacks upwind of this observatory for a couple thousand miles. So the air we're measuring here is what we would normally call clean air. It doesn't have any local sources of pollution. A visionary scientist named Charles Keeling began measuring the carbon dioxide in the air at Mauna Loa back in the late 1950s. And at that time, it was about 315 parts per million. Since that time, it has steadily risen to about 385 parts per million. And the reason is that we're taking this carbon in coal, oil, natural gas that's been buried deep in the earth for millions of years, and by burning it, we're rapidly releasing it into the atmosphere. When I say we're releasing it rapidly, this illustrates what we mean. Back in the first part of the 19th century, fossil fuel carbon emissions were basically zero. But then as the Industrial Revolution really began to take hold, we started using coal as a major source of fuel. Coal is the green line, the black line is the total. You can't see the green line because it's under the black line. What that's telling us is until the beginning of the 20th century, almost all of the carbon emissions were from coal. But then this blue line starts to take off, and that's petroleum. And so big swing upward after World War II in petroleum, so that petroleum surpassed coal. They've been sort of racing back and forth with petroleum usually ahead, but coal not very far behind. And then in the latter half of the 1950s, in the 20th century, natural gas began